Today is episode 1.7.2, which is Parallel RLC circuits. So welcome back to 1.7.2 Parallel RLC circuits. Over here we have 100 volts, 100 hertz AC sinusoidal supply. Over here we'll see the total current flow into the resistor, into the inductor, and into the capacitor. And we'll see it flow out if we had to clamp it, and it would flow back into the IT. This would also obviously be IT, right? All right, so let's start off with the inductive and capacitive reactances. So let's calculate the capacitive and the inductive reactance, which ends up being 2 pi FL 1 over 2 pi FC, the exact same calculation we've been doing the whole time in the series, now is applied in the parallel, and then we get our totals, which is 12.566, as well as our capacitive and inductive reactances. Right, after that we have to calculate the total impedance. Okay, so store this away, complete impedance of an RLC, parallel RLC circuit. All right, after that we put our two values that we've just determined into this parallel RLC impedance formula, and we find total impedance as 8.548 ohms. All right, good. So the next question is to calculate IT. IT is quite simple if you have total impedance. It kind of remains the same old Ohm's law formula that we apply over here. 100 volts over 8.55 ohms equals 11.698 amps. All right, so let's go and calculate the current in each one of the branches, IR, IL, and IC. All right, that's next. So what we do is we use the same old calculation for Ohm's law for each one of them and just apply their resistance in this case, inductive reactance in this case, capacitive reactance in this case, and then we surmise how much current is flowing in each one of those branches, right? All right, so now we've got current in IR, IL, and IC. Let's just go back to look at it quickly. It's each one of these branches over here. We've calculated IR, IL, and IC. My only question is, trick question, why does the value of IR plus IL plus IC not equal the IT, which we calculated from the total impedance? The reason thereof is it is a vectorial summation of the currents. Remember, the current in the resistor and the current in the inductor and the current in the capacitor are not in phase with each other at all. Yeah, so can we just add IR, IL, and IC? The answer is no. Okay, so what do we use? We use the parallel current formula. We have to use the parallel RLC current formula, which is this one over here. Formula IT is equal to square root IR squared plus, in brackets, IL minus IC, square the brackets. This is the formula, so it comes down to 11.7, and the whole calculation just checks out to the previous IT we calculated from ZT, which is total impedance, and we've proven it to be correct with the following formula. All right, guys, so now that we've covered parallel RLC, which is a little bit above NQF level 2, we will carry on with the syllabus 1.8 next.